Morning, everybody. My name's Jake. It's Saturday, July 26th, and today we have our 10 out of 10 puzzle. And so to start out, I'm just going to take a quick look around. I'm going to explain the steps a little bit more for these 10 out of 10s. So I'm just looking for ways to cut up the grid, the classic 45 rule we can see here and here. I think I want to start out with, because this can only be 7, 9, and we're 14 under. So these two cells have to add up to 14, which means that can't be a 7. So that's a 9, that's a 7, and because this has to add up to 14, that is a 5 there. And then here, we are also going to be able to figure out this digit. That'll give us that digit, which should give us that digit. Okay, so this is going to move around the puzzle quite well. That's a very easy start. So the 45 rule also extends outside of the cage. So all these are going to be over by about 13. And so we already have a 5. So now we simply just need an 8 there. And this is 36. So this has to sum to 9 here, which gives us 8 and 1. And then this will be 9 over, so then that's an 8, and then this has to be 15, so then that's a 7, and then that's an 8. Oops, yeah, there we go. Okay, and so now we can probably take a look at these sums here. So normally you wouldn't be able to figure it out with just this, but now since we have a 7, that means we're at 38, which means these two cells have to add up to a 7, which I do not want to put down yet, because that's not that restrictive. What about these? Plus an 8 gives us a 37, so these have to add up to an 8, which just does not help, because this 8 doesn't eliminate anything in the 6 or the 8 combinations. Now, this has to have a 1 in it, cannot have an 8, and that means where does our 8 go in this box here? 8's inside this cage, so it can't go in here. 8 can't go here, so this makes this an 8 too. We know the 8 there, so that's a 2, and then that's an 8. And there doesn't seem to be... Oh wait, the 2 will eliminate a lot of digits here, so we're left with 3, 4, 6. And then this will be 1, 5, 9, and 7, it looks like. 7 gets eliminated there. 8 will be removed from here. So where does 5 go now? 5 can't go in these 4. 5 can't go here because that would have to be with an 8. So we do know we need a 5 in one of these two, which should restrict it. That doesn't have a 5 or an 8 there. We're looking for combinations of 5 and 8 here, which can only be 2, 7, or 3, 6. But 3 and 6 are removed, so that's a 2 and a 7 there. 7 gets removed from there. And now 7 gets removed from here now, which leaves us with a 4 and 9. Should eliminate the 9s there. And then 9 has to go in this row now. 9 has to go in this row, which means 9 simply just goes there. And now, we do know this digit. This is 6 over, so now that must be a 2. And where else now? This is obviously 1, 3, 6, and 8. 1, 3, 6, and 8, but our 8 gets removed there. Now, what is left in this? Okay, so we said this has to add up to 8, so it's 1, 7, or 3, 5. Okay, there we are. Okay, yeah, because this sum was 29 plus an 8 is a 37, which means that these two cells must add to 8 in order to make 45. But it can't be 2, 6, so it's either 1, 7, or 3, 5. And now if this were to be 1, 5, then this would have to be 3 and 7, which adds to 10, so that doesn't work. So now we know this must be 2, 4. And now we can just remove all the 8s, 2s, and 4s, and that should be left with 1, 7, or 3, 5, but we do need a 6 down here, and we're going to need a 9 somewhere. But 6 can remove the 6 from there. Oh, that can't be 1, 7 anyway because of that. So that is 1, 7 now. So 7 and 6 now must go here, and then 1 and 9 must go here. Because that cannot be 3, 5. We need a 6, 7, and a 1, 9 there. This is 3 or 5. 3 or 5 with 6 is removed. Okay, we could have 3, 4, 5, 3, 2, 7, or 3, 1, and 8. Could this be a 5, 3, and 4? That could be 5, 7 there. Let's see, what else do we have? This had to add to 7, so it's not too restricted yet. What's the value? That doesn't seem very restricted. I mean, we know it can't have a 2. We do know 1 is going to have to go in here because 1 can't go in here in either of those. So that does limit it to 1. And we can get rid of any 5, 8 combination, but it doesn't exist in there. 5, 8s. We can also get rid of the 2s, but not very helpful. Where does 6 go? 6 also can't go in a 12 cage. So now 6 has to go here or here. That means we do need a 6 in here, and then it's 3, 9, 4, 8, or 5, 7. It's whatever missing pair is here. So we need a 6 and a 1. And now, so what else do we have? 3, 5. Oh wait, that can't have a 1 in it. So it's either 3, 2, and 7, or 3, 4, 5 in some combination. Okay. 2s have to go here somewhere. 2s and 4s have to go somewhere, but we don't know the last digit. Ones have to go. Now, so could this be 3 and 9? Could be 1, 3 here. Maybe we take a look at this. So 7s are gone from here. 1, 6, 8. It needs a 9 in it, obviously. It also needs to be an 8 because this has to add to 7, this has to add to 7. So it needs both an 8 and a 9 in it. And then we're left with the last of the 1, 6, 2, 5, 3, 4 that doesn't go here. Okay. I want to take a look at this again. Could this be 3 and 4, 5? Or could this be 5 and 3, 4? Because if this weren't to be a 5, then this would have to be a 3 because of that other combination. So that would be very helpful if this could not be a 5. So if this were to be 5 and 3, 4, 3, 4, 5, 7, 3, 4 is specifically 5 and 7. but I don't think that helps at all. 5, you'd get a 3 here. 3, 4. And then this cage is not very restricted. Oh, well, the 7s can't go down here. So we know 7s have to go here. And now we get a 1, 5, 9. So we need some sort of digit, which 2 is gone. So 2 must go here, because none of these cells have a 2 in them, and then 2 gets eliminated there. So this makes this a 3 or a 4, because it's a 1, 5, 9 triple. And we know 2 has to go here somewhere. And what else? Is there any more Sudoku we can do that would help us out a lot? 4 can't go here. 3, 5. This eliminates the 5 from there and the 3 from there. So 5s have to go in here somewhere in one of these two spots. 3, 4. 4, 6, 1, and 9. Not very restricted. There are 2, 4, 1, 5, 9, 3, 4, 6. I mean, 4 is eliminated from there as well. 4, 6, 3, 6, 3, 4. Now 7 has to go here somewhere. Man, I'm really lost here. 2s are eliminated. 6s. 6s have to go there or there. So that places a 6 somewhere here. Again, it's just not very helpful. And maybe I'm just looking in the wrong spot. Well, that's obviously a 4, then that's a 9. So that removes the 3, 4. So it's 1, 6 or 2, 5 here for that 7 cage, but it can't be 2, 5. So that makes that a 1, 6 there. So that removes 1 and 6. And now that removes 1, 6. It's 2, 5 or 3, 4 still. Okay, 2, 5, 3, and 8. So now where does our 5 go in this row? 5 is eliminated from there. 5 can't be there. So now that must be a 5. That's a 2, 7 pair there. So it's 2, 3, and 8. Which I don't really want to mark yet, but 1, 6. 1, 6 is removed from there. We have a 2, 5, 2, specifically 5 and 2, or 3 and 4. 2, 3, 8. So this can only be 3 or 8. This can only be 2 or 3. Now, the 5 and the 9 are missing. So now, 1, 6. Maybe we take a look over here. This can only have a 1 or a 6 in it. And there's no 8s are removed from here because of that. And 3, 9. So this has to be, couldn't be a 4 and a 7. That's not a pair there. No. 3, 4. 2, 5 or 3, 4. So this is either a 2, 5 or a 3, 4, which in combination with this will form some sort of X-wing. So if it is 2, 5, then we end up with a 5 and a 2, so 2 and 5 have to go there, or it's 3 and 4. So the digits of these two cells will go here. So this is either 2, 5, 3, 4, 2, 5, 3, or 4. And now, where Where does our nine has to go in this cage, which is placed there. That's still unhelpful. And so let's have a 2, 3, 2, 5, 3, 4, 6. Well, I don't think these are possible. I don't think either of these are possible, because if this were to be a 6, then you would end up with a... So let's say it was 5 and 2. And then you would end up with a 5 there. But that would break... Is this logic bi-implicational? So this is one of the things I learned. I'm a math major, by the way. And so in proofs, there's this concept of one thing proving another. Just because X implies that Y exists, just because this 2, 5 implies 2, 5 goes here, doesn't go the other way around. Does 2, 5 being here imply 2, 5 must go there? Maybe I'd screwed up that. Whatever goes here must go here. But let's just say this were to be 2, 5. Could 2, 5 go here? And then could 3, 4 go here? No, because then what would be the only digits here? The other pair must go here. So that doesn't work. 2, 5, 3, 4 doesn't work, because then you're left with an 2, 5. Yeah, because one of those needs to be a 9 there. So I don't believe this could be 2, 5 or 3, 4. Because, yeah, you'd need a 2, you need the other 3, 4 here. Oh, wait. Yeah, the question is, could this be 2, 5? Let's just say it was 2, 5. This was 2, 5 here. Then you end up with a 3, 4 here, and then you'd need a 2, 5 here. Because 1, 6, 7, 8, and yeah. And then if this were to be 3, 4, this would be 2, 5. This would have to be 3, 4. And then, yeah, so whatever goes here does go here. So it is bi-implicational, as we would say. But let's just say this were to be 2, 5. Then this would have to be 2, 5. And then we'd eliminate the 2s and 5s by an x-wing. So this couldn't be 2, 5 or 3, 4 in there. So that has to be a 1. And then that has to be a 6, which gives us 6 and 7. And then we only end up with 3 or 5, so we can eliminate the 2s and 4s there. And then we can also eliminate 3 and 5 from here. So now that has to be a 7 or a 9. And your other one goes, where does our 1 go? It must go here somewhere. So now we need a 1 and a 6, which is not very restrictive, but in combination with the 3 or the 5, this doesn't have a 3 or a 5 there. So it can't really be both 3 and 5, obviously. It does need an 8 here, which must go here somewhere. So we have our 1, 6, 8, our 3 or our 5, and then we need a 3 or 5, 1, 6, 2, 9. We need a 2, 9, 2, 7, or 3, 7. Or 4, 7. 2 or 4 in that box. So that leaves 2 or 4 here. And then 3, 7, or 3, 5 in any combination here. I think we can deduce this digit by the same logic here. So if this were to be 4 and 3, then you'd end up with a 3 and a 4. 3 and a 4. No, that doesn't help. Okay. I mean, maybe, but I don't really feel like thinking it through right now. So our 8 and our 9 must go here. That removes 8 from there. Now, 1, 3, 6. This digit is nagging at me. This has to be... I feel like I know the logic to get this combination, but I don't know why I can't think it through right now. So if this were to be a 5, then you would definitely get a 4 here and a 3. Oh, that can't be a 5. Because if this were to be 5, then you would need a 4 here and a 3, but this would also need to be a 3. So that doesn't work. So no matter what, that's a 3 and that's a 5 there. And so you end up with a 5 or a 7 there now. So 5, 7 no longer works because you get 3, 2, 7 or 3, 4, and 5, yeah. 5, 7 no longer works there. 3, 9 or 4, 8. And then this now needs a 5 in it. And it seems that there's only one way that works, which is we have our 1, 5, 6, and 8, so it has to be 2 and 7 in here now. So 7 is removed from there, 7, which leaves us with our 3, 5, and our 4, and 1, 9, and our 3, which makes a 2, 5 here, which goes 2 and 5, and then 3, 4, which makes 4 and 3, and 4 and 2. Yeah. And now what are we left with? We need 1, 8, 2, and 7, where 2 must go there or there, and then 7 actually must go there. Okay, so now 4, 8 is removed from here, so that does leave us with a 3, 9. 3, 9 is removed from here, 4, 8 is removed from here because of that. So now that must be 5 and 7 in that order because of that digit. And now 1, 6, and 4, and 8. So now we know 8 must go here. 4 must go here or here somewhere, which does make a 6 there. That's a 1, 4. 8 is given, 1, 4, 8 is given there, 2 and 8 are given. Now we know all the digits. In this row, 2 must go here. We're missing a 7, which must go here. We're missing a 3 and a 5 here, which is not done yet. And then we're missing a 6 and a 4 here. 4 is given there and 6 is given there. So 6 is removed from here. And 2 and 4 don't go anywhere in these. So 1, 3, 5 there. And now I'd imagine it's just a bit of Sudoku to finish this out here. So we're missing 2, 3, 7, and 9 it looks like. Yeah, 2, 3, 7, and 9 in this row, but 7's down here, so that makes a 2, 7 pair. That makes a 3, 9, which must go here and here. That makes that a 4 because of that. That makes that a 3, 6, and 4. And now we're missing 5 and 1, so our 9 must go there. 9 can't go in that row, and then that makes that 1, 2, 3, 4, 5, 6. And that makes that a 1, 5, 9 there, 5 and 3. 3, which gives us our 1, 3, 6, 8. 3 is removed from there. And 5 there, 1 there. 3 and 9 are not given yet. Our 1s must go here, except that, and that. Our 2s, our 3s now must go somewhere here, here, here. I don't want to pencil mark that yet. because 4s must go here or here. So 4s, oh wait, no, that has to be a 4, 4, 4, so that must be a 4. 5s, 6s are given here and here. So this is a 6, 3, or a 9, 6, 3, or a 9 there, and then this is a 3 or a 9 there. Wait, no, I messed that up. 9 goes there, 3 goes there. So that's a 6 or a 5, wait. Wow, 6 or an 8, 6 or an 8. 8's there. So that's 6, that's 8. That leaves us with a 3 there. 3, 8, 6. You can hear the keyboard clicking very loud because I get excited as we finish up this puzzle. We have gotten a pretty decent time here. And that's the puzzle in 25 minutes and 46 seconds. We can check our solve time, 30 minutes, 30-minute average, so not the best, but that was a good one.